we are moving on to 6.7. And 6.7 are inverse functions. The very basic way to explain what an inverse is that we switch x and y. Okay, those flip around. At the same time, that also means that if we are switching those, that this would reflect over the y equals x line. So for example, the y equals x line is a perfect diagonal right through the origin, right? So if I have something that is graphed up here, the inverse to that graph would be over here. That would be the inverse. It would be reflect right over it. Hold it right on that dotted line, it'd reflect over. So for example, let's say the vertex to that parabola right there is the point 0, 4. When that reflects over, the vertex of it over here is actually 4, 0. The x's and y's flip. Okay, so that's where we are headed today, or what we're going to talk about today. Before we get any further into it, I want to talk about the fact that this one, the domain to this, of course, you know parabolas. The domain to all parabolas is negative infinity to positive infinity. The range to this parabola would be a bracket 4 to infinity. Let's talk about that one. First of all, the domain at this one, remember, domain is your x values. It starts at 4 and goes to infinity. The range has arrows going up and down, so the range goes from negative infinity to positive infinity. What do you notice about the domain and range on the inverses? They flip, exactly. Because again, domain is x, range is y, so they flip places. Okay? With that in mind, I want to start off really, really easy. So the first couple of problems, you have a table and you have to graph the relation. So here is example number 1. And this is going to cover your 8 through 10. Find the inverse and graph the given relation and the inverse. All right, so you're going to be on the first couple. They're going to give you a table. Here's x, here's y. Let's say, let's go 3, 2, negative 4, 5. Negative 1, 7, and 2, negative 3. Okay, so this is my original one. I'm going to go ahead and plot these points. So this is my original. So I would plot 3, 2. So 1, 2, 3, 2. Here's my first one. Then I have negative 4, 5. 1, 2, 3, 4. Up 5. Negative 1, 7. And 2, negative 3. So you'll notice I have 4 points there, right? Okay. I'm now going to find my inverse. And again, I can't connect those points, right? It's not a function. They're just points. Okay, so now I'm going to do my inverse. When I do my inverse, I have x and I have my y, and inverse is a little -1 at the top of your y. We're going to switch them. So this now becomes 2, 3, 5, -4, 7, -1, and -3, 2. Now let's plot these. So I have 2 and up 3. I have 5, down 4, 4, so right here. I have 7, -1. And we have 2, -3. Or sorry, -3, 2. My bad, -3, 2. If I had that perfect diagonal line right here, what do you notice about each of those points? They reflect over each one, right? This reflects, those reflect, those reflect, and those reflect. Okay, so that's all you have to do for the first couple. Is flip the numbers and plot both. Okay? Now, if it is in function form, so not in a table, we have some steps I'm going to ask you to follow. So, to find the inverse algebraically. Step 1, switch x and y around. Step 2, solve for y. Step 3, write with inverse notation. Inverse notation is either written as y with a little -1, or if it's in function notation, f with a little -1 of x. That means inverse. All right, so if I have, here's example number 2. Let's say I have y equals, start off with a really easy one, 3x plus 5. And I want you to find the inverse. So step 1, we switch those around. X equals 3y plus 5. Now we solve for y. So I'm going to subtract 5 over. So x minus 5 equals 3y. And then I would divide both sides by 3. And then write with inverse notation. Y inverse equals. I can leave it as x minus 5 over 3, or I can split it up. It's up to you. It doesn't matter. Either way. Okay? Any questions on that process? Seems pretty easy. Switch x and y and solve, right? Okay. We're going to take it one step further. Here is example number 3. This is what you need to do for 12 through 20. Find the inverse and is the inverse a function? How do you know if something is a function? You use the what test, especially if you're looking at a graph. Yeah, the vertical line test, right? The pencil test. Okay, so keep that in mind as we do this. So, let's say you're given something like, let's do one like this. Let's say I have y equals, let's go x squared plus 6. All right. So first thing is, who can tell me what is that we have up there? Y equals x squared plus 6 is a what? It's a parabola. Yeah, x squared. It's a parabola that moved up 6 spaces, right? It would have looked like this. 1, 2, 3, 4, 5, 6. Parabola that goes like that, opens up because it's positive. Okay, so now we're going to find the inverse. First thing we do is switch x and y around. So I'm going to have x equals y squared plus 6. Now I want to solve for y. So I'm going to subtract 6 over. So x minus 6 equals y squared. How do I get rid of a squared? Square root both sides. And when you square root a variable, what do you have to put in front of it? When you square root a variable, thank you, plus and minus. All right, so I actually get y inverse equals plus and minus the square root of x minus 6. This one, if I were to graph that one, I think it's easiest for you to see it this way. This means I would go 1, 2, 3, 4, 5, 6 to the right, and it would be a parabola facing this way. Is the inverse a function? No, it is not. So not a function. Questions? Huh? Because the inverse is not a function, because if you were to draw a vertical line down, how many times does it cross through that? Crosses through twice, right? Okay. So sometimes you can look at the original and do what we call the horizontal line test, right? Yes. Yes, that's correct. Okay. 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 All right, let's keep going. All right, so any questions here? Because I need to take it again one step further. Doing okay? Okay, so here's example number 4. This is what you are going to do for, go 22 through 28. Graph the function and its inverse. So I want to start with, let's go y equals 2x plus 3. All right, so to find my inverse, I first switch x and y around. So I have x equals 2y plus 3. Now I solve for y. I subtract 3 over and divide by 2. So y inverse equals, I'm going to write it as 1 over 2x minus 3 over 2. Right? That's the same thing? Okay. So I'm going to come over here and I have to graph both of them. First one to graph, how do I graph a line? I start where? I'm going to graph this one first. Yes. That is a 3. Yeah. So we're going to start at 3, right? And then we're going to do our slope up to and over 1. And I'm going to connect my dots. So here is my original function. Now I want to graph my inverse. So I'm going to start at negative 3 halves, which is negative 1 1/2. And I'm going to go down 1 and over 2. I'm going to connect my dots. Oh, not quite connecting my dots. There we go. Oh, I just did that wrong. Yep, I went the wrong way with my slope. Sorry, guys. My bad. I apologize. Okay, so first of all, we start at negative 3 halves. My slope is up 1 and over 2. So I'm going up 1 and over 2 and connecting my dots. There we go. That looks much better. How did I automatically know that that was not the inverse? What is it supposed to reflect over? Yeah, it's supposed to reflect over that diagonal line right there. We did. Yeah, it's right here. -3/2 is right there. Down 3/2. All right, let's try another one. Let's go example number 5. That one worked. Yeah. Okay, example number 5. 30 through 34. We are going to find the inverse. And the domain and range of the relation and the inverse. So let's say I have f of x equals the square root of x minus 3. So, before we find our inverse, let's find our domain. Is there an x in the denominator? Is there an x in the square root? Okay, so we would take x minus 3, set it greater than or equal to 0. So x is greater than or equal to 3. So my domain would be a bracket 3 to infinity. My range. Range are your y values. If I have a square root, my y values can only end up to be what? Okay, let's try this again. Your range is your y values. No matter what I put in here, because I can only put 3 to infinity, what is the very smallest this can be no matter what? It's a square root. What's the smallest it can be? Okay. If I take the very smallest domain and put it in here, 0. It's a square root. Can I get any smaller than 0? Okay, so my range, the very smallest the range for this function can be is 0, because you can't get a negative out of a square root, right? Okay, so my range goes from 0 to infinity. That's my original function. Does everybody understand that? Yeah. Now we're going to find our inverse. First, we're going to switch x and y around. So I have x equals the square root of y minus 3. To get rid of the square root, what do I do to both sides? Thank you. So this would be x squared equals y minus 3. And add 3 to the other side. So I get my y inverse, or my function inverse, as x squared plus 3. So now, since I've already done my domain and range of my original function, my domain for the inverse is 0. And my range. Correct. Okay, they just flip spots. Okay, if there's a question you guys ask me, go ahead. Why 0? Okay, because the original function was underneath the square root, so it can't go any smaller than that. You know what I mean? So I know if you just saw this, Without this notation, if you just saw that, that would be a parabola and it would be everything, right? But because it's the inverse, it only really has half of it. It's only got the positive side because of that. Yes?
So I understand we're doing like the domain on bottom to get the top to the top one, but if there's no x in the squared or x in the bottom, why is it negative infinity?
Again, that's exactly what Maria was just asking me. So, yeah, I'm just going to clarify for everybody. Make sure that we're all understanding. The original function, was there an x under a square root? Okay, which means it was only the positive side. If you were to graph this in your graphing calculator, it would look like this. It would go 3 to the right, it'd start right here, and it'd curve over, and that's it. Okay? So then when you reflect that, when you change it to the inverse, technically all we have is the positive side of this, and it looks like that. So we really don't have the negative side when we're doing the inverse of it. That's why we always start with our original domain and range and flip them down here. Did that answer that question better? Kind of? Okay. Again, well, I want to make sure we're understanding it. I want to make sure we don't have any questions regarding any part of it. You've always got to start with the original. The original gives you restrictions to it. If this was the original function, without this little inverse thing, I totally agree the domain would be negative infinity to infinity. But because it's the inverse, it has restrictions to it. Okay? Okay. All right. Last thing I want to talk about is composites of F with F inverse. So we're compositing F and its inverse together. So let's say I have a function F of X. That is, 3x minus 1. If I were to find its inverse, so let's find its inverse together so we can talk about this. We would first switch our x and y around. So I'd have x equals 3y minus 1. Add 1 over, so x plus 1 equals 3y. And so my inverse, I would divide both sides by 3. So my inverse would be x plus 1 over 3. Do we agree with that? Okay. So now I want to show you what happens when you composite or you cross them together. If I have f of f inverse of 3, I would take 3, plug it into my f inverse. So I put 3 in here. 3 plus 1 is 4 over 3, right? Then I would take my 4/3 and plug it into f. So I'd have 3 times 4/3 minus 1. 4 minus 1 is 3. Let's try another one. I can even go the other direction. What if I said my f inverse of f of negative 7? So I'm going to take negative 7, plug it into my f. Okay, so negative 22. And then I'm going to plug that into my inverse. So I have negative 22 plus 1 divided by 3. Negative 7. Are you noticing something about crossing a function with its inverse? Putting in, yes. That's what I wanted you to notice. Anytime you cross a function with its inverse, when it's composite like this, whatever you put in, you get out. Whatever you put in, you get out. Okay, so that being said, here is example number 6. And this is the last 38 and 40. I have h of h inverse of 10 equals Exactly. I have G inverse of G of negative 13. Negative 13. I don't even need the functions, do I? All I need to know is if I'm crossing a function with its inverse, whatever I put in, I get out. Okay? So literally the last two problems in your homework, that's all you have to do. They're written just like that. Whatever you put in, you get out. So if I have f of f inverse of 27, okay, will I have questions on these tomorrow? All right. You guys still have about 6 minutes left, 6, 7 minutes. I know there's going to be questions. It's the first time you're doing inverses of domain and range, okay? But I need you to try them so I know where we're going with it, all right? I need to make sure we're understanding it before we can continue. All right.